Hi all, this is Vijay. So today I would like to work on the solutions for the Cambridge AS and A level pure maths paper. Code is 32. This is Feb March 2022 session. So pure maths 32. So I would like to start off with question number 1. So question 1 is solve the inequality modulus of 2x plus 3 greater than 3 times of modulus x plus 2. So the first step you're going to do is squaring on both sides. So when you square on both sides, so this becomes a 2x plus 3 whole square greater than, so 3 square is 9 times of x plus 2 whole square. Now we can expand 2x plus 3 whole square using either the multiplication or by applying any uh, algebraic identity, which is a plus b whole square equal to a square plus 2ab plus b square, or you can simply multiply. For example, 2x plus 3 whole square is 2x plus 3 times of 2x plus 3. So when you multiply, 2x times 2x is 4x square, 2x times 3 is 6x, then you have 6x, then 3 times 3 is 9. So you get 4x square plus 12x plus 9. Similarly, for x plus 2 whole square, it is x plus 2 times of x plus 2, and that is x square plus 2x plus 2x plus 2 times 2 is 4. So finally you get x square plus x square plus 4x plus 4. So you can put the terms here: 4x square plus 12x plus 9 greater than 9 times of x square plus 4x plus 4. So when you multiply 9 with the entire terms in the brackets, you get 9x square plus 36x plus 36, and here you have 4x square plus 12x plus 9. And take all the terms to the other side. So the 4x square, when you shift to the other side, becomes negative 4x square, and you have 9x square here. So 9x square minus 4x square, and then 36x minus 12x, then 36 minus 9. So here the inequality, this is what you have. So this will give you 5x square plus 24x plus 27. The other way of writing this is 5x square plus 24x plus 27 less than 0. So this is a quadratic inequality for less than 0, whereby you get the roots in between. So the solution is in between the two roots. So 5x square plus 24x plus 27, how do you solve this? So you can multiply 5 times 27. The simple way is to split the 27 by writing 3 times 9. Most of the times it works. Now make a combination of 5 and 3, 15, and then 9. So 15 plus 9, when added, you get 24. So 5x square plus 15x plus 9x plus 27 less than 0. So taking 5x common, you get x plus 3. Then taking 9 common, you get x plus 3. X plus 3 less than 0. Therefore, you get x plus 3 times 5x plus 9 less than 0. So if you solve this equation, You get the two x values. The two x values are, one is -3, one is -9/5. The solution here is x will lie between the two roots. So this is how you solve the question number 1. Now moving on to the question number 2. On a sketch of an argon diagram, shade the region whose points represent complex numbers z satisfying the inequalities modulus of z plus 2 minus 3i less than or equal to 2 and argument of z less than or equal to 3 by 4. So when you look at this question, you have to understand that this will give you a circle and this will have to give you a line. So let's uh, work out on this now. So you can rearrange this way, less than or equal to 2. The format is always z minus z1, I mean modulus of z minus z1 less than or equal to some a or some constant. Here z1 is the center of the circle, so which means your center of the circle is -2, 3, and the radius is 2 units. So that is one. Working out for the argument of this z is less than or equal to 3 pi by 4, and you know it is nothing but argument of z is nothing but tan inverse of y over x less than or equal to 3 pi by 4. So y by x less than or equal to tan of 3 pi by 4, which is -1, which means y less than or equal to -x. Or you can convert this argument z less than or equal to 3 pi by 4 to a straight line y less than or equal to -x. Or you can also understand that the angle made by the complex number z, the line joining the complex number z to the origin, makes an angle of 3 pi by 4 or 135 degrees to the positive direction of the x-axis. Now let's draw this. So it's a sample sketch. You can draw the x and y axis. So this is the real axis here, and this is the imaginary axis. It's called the argon diagram. Now the center here is -2, 3, so -1. Let's try to make an accurate, I mean not an accurate, but very close to the accurate scale. So -1, -2, and 1, 2. So I think it's as close as possible. So this is -2, and this is 3. Therefore, your center is this. Now the radius is 2 units. So I have 2 units to the right. Similarly, so 3, 4. So 2 units to the left and 2 units down. 2 units. Draw a circle. You can use a compass when you're working on the board paper. So this is a circle. Now, so the circle is drawn. Now we can use the for the argument z less than or equal to 3 pi by 4. So since it is y equal to -x, you can use the points -1, 1 and -2, 2, and you can draw a line. It's a line joining the origin, passing through the origin. So this is your, if you see, this angle is 3 pi by 4. Now, so the solution is asking for in betweens. It has to be within the circle. The radius given the radius is 2 units, and it should be also lying within the angle. That's how you shade the inequality. So this is how this question works out. So let's move on to the question 3. So let's make a note of the 2 points. The 2 points is 0.31 comma 1.21, and the other point is 1.06 comma 0.91. So now what is given is x power n y square equal to c. So taking log on both sides, taking log on both sides. Please do not use log because it's already been instructed that we are supposed to use the natural log. So we should be cautious on that. So ln of x power n y square is ln c, or the log c. Now they can split this using the rules of logarithms. Log of ab is log a plus log b. So we'll consider x power n as one quantity and y square as another quantity. So log of y square equal to log c. Now log of ab is log a plus log b, and also log of a power m is m times log a. So here you'll use n times log x plus 2 times log y equal to log c. Make log y as a subject. So 2 log y equal to minus n log x plus log c. Therefore log y, so when you divide by 2 on either side, get log y is equal to minus n by 2 log x plus 1 by 2 log c. Now if you consider log y as capital Y and minus n by 2 as the gradient, let's say m, and log x as capital X, this is some constant, let's say k. So this equation is nothing but a straight line equation or a linear equation, y equal to mx plus c, where the gradient is m equal to minus n by 2 and the y-intercept k is half log c. Now let's see how we can find the gradient. We already knew the 2 points, so let's use the 2 points. So y2 minus y1 by x2 minus x1. So 0.91 minus 1.21 divided by 1.06 minus 0.31. So this is the gradient, and if you use a calculator, you would get minus 2 by 5. Check in the calculator. Therefore m is equal to minus n by 2, and minus n by 2 is minus 2 by 5. So from this we get n equal to 4 by 5. That's the n value. Now to find the c value, you can plug in any point. So minus n by 2 log x plus half log c. You can use this equation. Since we're looking for c, you can straight away use this equation. It'll become more easy. Therefore log c equal to n times log x plus 2 log y. So I'm thinking of to consider the point 0.31 comma 1.21. Log c equal to n is 4 by 5. Log x, the point is 0.31 plus 2 times of the log y value is 1.21. Please do not substitute the point 1.21, the coordinate, in place of y, because this is a graph between log x and log y. you have to take the coordinates as it is. So your log y is 1.21 and your log x is 0.31. So from this, when you calculate, what you get, let's see, 4 by 5 times 0.31 plus 2, I think it this is, yeah, 2 into 1.21, that will give you 2.668. This is 2.668, that's your log c. Therefore c is, by default, you know the base is e, so e power 2.668, that will give you, so in the calculator what you can do is, for using the Casio FX 991 ES plus, you can simply press shift ln, so you get the e or something, and then you can type in that 2.668, thereby you get 14.41. So what's the question? Our question is to find the value of n and the value of c. It says 2 decimal places. So this is the exact value. 4 by 5 is 0.8, and therefore you can conclude that your n value is 0.8, 2 decimal places. The c value is 14.41. Hope this is clear. So let's move on to the question number 3. So here, so guys, what do you think of this concept is? Now, x is in terms of the parameter, y in terms of the parameter theta. So this is something to deal with parametric equations, and the differentiation with the parametric is nothing but the parametric differentiation. So this is the concept of parametric differentiation. What are the sub concepts of your differentiation topic? So here, what we have is, you have x equal to 1 minus cos theta, then you have y equal to cos theta minus 1 by 4 cos 2 theta. So differentiating x first with respect to theta, you get dx by d theta is 1 differentiation is 0 minus cos differentiation is minus sine theta. That will give you sine theta. Negative of negative is positive sine theta. And dy by d theta equal to, cos differentiation is minus sine minus 1 by 4. What is the differentiation of cos 2 theta? It's negative sine 2 theta times, you have to use the chain rule here, differentiation of 2 theta is 2. So that will give you negative or minus sine theta. So minus into minus is plus, and the 2 cancels out the 4 here. So you get 1 by 2 sine 2 theta. Now we got the expressions for dx by d theta and dy by d theta. So now let's find what dy by dx is. That you can find dividing by dy by d theta with dx by d theta. So dy by d theta is minus sine theta plus, so half sine 2 theta divided by minus sine theta plus half sine 2 theta divided by sine theta. You can use the double angle formula for sine 2 theta. That is nothing but 2 sine theta cos theta. So when you do that, the half get cancelled with the 2. So 2 and the by 2, I mean the 2 and the denominator get cancels off. So you get minus sine theta plus sine theta cos theta divided by sine theta. So that will give you, take out Sine theta common, we can get sine theta into cos theta minus 1 divided by sine theta. You put sine and the sine gets cancels off. We're still not yet done because it's asked to prove that dy by dx is negative or minus 2 sine square half theta. Now how do you proceed from here? We know the double angle formula for cos 2a is 1 minus 2 sine square a. So you can replace the 2a, replace the 2a with theta, which means your a is half theta. Therefore, this becomes cos theta equal to 1 minus 2 sine square half theta. So make the 2 sine square, get the 1 to the other side. You get cos theta minus 1 equal to minus 2 sine square half theta. I have shown you the working here, how cos theta minus 1 is minus 2 sine square half theta. So this will give you minus 2 sine square half theta. So this is how you keep working out with the double angles wherever it's needed. And some of you might get a doubt that the double angle formula for cos 2a, why it's also like 2 cos square a minus 1. Why don't I use this? You cannot use this here because ultimately we're looking for in terms of sine. So that's how you decide whether which double angle formula for cos has to be considered. Even if you use or get in terms of cos, finally again you would convert the use the trigonometric identity sine square plus cos square equal to 1, and then change the cos square to sine square. It will take some more time, which is not needed. So hope this is clear. So that's the solution for the earlier question. Now moving on to question number 5. So here this is a 6-mark question. I forgot to tell you in the beginning that what is your stand or how do you manage the time while solving the past papers. Remember, this is a 6-mark question. You can check the amount of time I'm spending here. It's a 6-mark question. The time amount that you spend is 6 minutes. That's how you need to work out. I know sometimes it's not easy to spend the exact time, but some questions take less time because when you're confident, you can easily solve those questions. So the extra time that is left out for you at the end, you can work on the question that you felt which is hard or you want to come back to later, and also you can verify your working of all the questions. So this way you have to manage the time, right? So tan of alpha plus beta is given as 2, and tan beta and tan alpha is 3 tan beta. What is tan of alpha plus beta? Here we're going to use the compound angle for tan of alpha plus beta. So compound angle for tan is tan A plus tan B by 1 minus tan A tan B. So here it is tan alpha plus tan beta by 1 minus tan alpha tan beta equal to 2. Now you substitute the tan alpha with 3 tan beta. 3 tan beta plus tan beta by 1 minus 3 tan beta into tan beta equal to 2. 3 tan plus tan is 4 tan beta divided by 1 minus 3 tan square beta. You can cancel the 2 and the 2 here, whereby you get 1 here. So you get 2 tan beta. You can cross multiply this 1 minus 3 tan square beta, bringing all the minus 3 tan square and 1 to the other side. You get 3 tan square beta plus 2 tan beta minus 1 equal to 0. This is a simple quadratic equation in terms of tan beta. So it's nothing but 3x square plus 2x minus 1 equal to 0. X is nothing but tan beta. So when you solve this equation, this is simple. It can be simply factorized. So 3 into minus 1 is minus 3, which can be factorized. The two numbers when you multiply can be considered as 3 and minus 1. When you add, you get plus 2. So 3x square plus 3x minus 1 equal to 0. So 3x into x plus 1 minus 1 into x plus 1 equal to 0. Therefore, you have x plus 1 times 3x minus 1 equal to 0. Therefore, you have x equal to minus 1 comma 1 by 3. Now, this is nothing but tan beta. Tan beta is 1 and tan beta is minus 1 and tan beta is 1 by 3. Now, we already have tan beta. So, we can easily calculate what tan alpha is. So, tan alpha is 3 times of tan beta. So, it's minus 3. And tan alpha here is 1. So you can take each one separately and then work it out. So tan alpha is negative 3 and tan alpha is 1. Then you have tan beta is minus 1 and tan beta is 1 by 3. This is a standard value, so it is 45 degrees. Please check whether it's given in the radians or degrees. So this is in degrees. So remember to put your calculator in the degrees before you move on to the calculations. If it is in radians, change the mode to degree, then work it out. So here the principal value of alpha is, it's simply tan inverse of 3. That will give you, tan inverse of 3 is 71.656 degrees. 71.56 degrees. Tan is negative. This value is negative here, so tan is negative in the second quadrant. So it will be 180 minus of that. So 180 minus the answer, that will give you 108.4 degrees. Angles are always rounded to 1 decimal place, we know that. Similarly here, the principal value of beta is 45 degrees. Tan inverse of 1 is 45 degrees. Tan is negative in the second quadrant. So 180 minus 45, which is 135. If you want, can still use the quadrant diagram for the sine, cos and tan. This is the first quadrant where sine, cos, tan all are positive. Sine is positive in the second quadrant, tan in the third, cos in the fourth. Here the angle pattern is, this is theta here. It's less than 180, so 180 minus theta. And here it is 180 plus theta. And this is 360 minus theta. Theta taken in the anti-clockwise sense, positive. So coming to beta here, so tan inverse of beta will give you 1 by 3, tan inverse of 1 by 3, 18.4 degrees. Therefore, you will write the final conclusion. Alpha is 45 degrees, 108.4 degrees. Beta is 18.4 degree and 135 degrees. This is how you solve the question. So let's now move on to the question number 6. Now this is a complex number question. So whenever you're working on any question, please make a note of certain conditions given. So your complex number format is always x plus iy. Of course, x and y are x is the real part, and here y is the imaginary part. iy is imaginary. So here x and y are considered as real. Now let's say consider w as x plus iy. Now what do you think the conjugate of the conjugate is? The w star, which is x minus iy. Now let's also find what w square. So w square is nothing but x plus iy times x plus iy. So x times x is x squared plus ixy. When you multiply x with iy, iy with x is ixy, and iy into iy is I square y square. I think most of you remember how the concept of the complex number started. The root of -1 is defined as I. Squaring on both sides, you get I square. Now multiply I with either side, you get I cube is minus I. Either you square this or you multiply one more I to this, you get 1 equal to I power 4. So I square is -1. So you have x squared plus 2I xy minus y squared. Now let's take this equation w square plus 2iw star. The conjugate of it is 1. So w squared is, right, the real and the real part is x square minus y square. The imaginary part is 2ixy and 2I into x minus iy equal to 1. X square minus y square plus 2ixy. 2I into x is 2ix. 2I into minus iy. I square is -1. There's already a minus, so it becomes plus. It becomes 2y equal to 1. Now you can make this as a, you can also get the 1 to the other side. So you put all the real parts together. X square minus y square. There's a 2y here. When you get the 1 to the other side, that's also the real part. And here you have, take the imaginary, writing them aside like 2xy plus x equal to 0. Now here equal to, when you say equal to 0, it means it is 0, the real part is 0, and also the imaginary part is 0. So when you compare the real with the real, and you also compare the imaginary with the imaginary. So this will give you two conditions. Let's see what are those two conditions. So we get x square minus y square plus 2y minus 1 is 0. The other condition is 2xy plus 2x equal to 0. So from this you can take out 2x common, get 1 plus y equal to 0. So if you solve this, you get x equal to 0, y equal to minus 1. Now let's substitute this x equal to 0 and y equal to minus 1 in this. So when x is 0, get x squared minus y squared plus 2y minus 1 equal to 0. X is 0 here, so you get minus y squared plus 2y minus 1 equal to 0. Therefore, it is y square minus 2y plus 1 equal to 0. Y minus 1 whole square is 0. Therefore, y equal to 1. Therefore, when x is 0, y is 1. Now when y is minus 1, when y is minus 1, you have x square minus 1 plus minus 2. Again, you have minus 1 equal to 0. So this will give you x square equal to 4. You have x square x equal to plus or minus. There's a condition given that the real part of w is always, it can be 0, but it has to be negative, 0 or negative. So in this case, you're going to consider x equal to -2 only. Therefore, the two complex numbers, one is W is x plus iy. One complex number is, when x is 0, y is 1, so 0 plus I into 1, so that will give you y, I. That will give you I. The other complex number is x is minus 2 plus y is minus 1. So that will give you minus 2 minus I. In maths, we know that we cannot write in one line more than two equal to signs, but to minimize the space, I am showing my working this way. Please do not mind. Thank you. Now let's move on to the next question, which is, yes, this is a trigonometric sketching question, and I see that most of the people have a difficulty on working on this question. Now let me tell you an easy way to work out this question. It's very, I mean, it's not that easy to remember the sketches of the secant x or the cosecant x or the cot x, but there's a way to remember to make the graph look simple. So let's see how we can do this. We know the secant x is nothing but the reciprocal of cos x. Yeah. So secant x or secant of half x is nothing but 1 by cos of half x. So let's have an idea of what cos of half x is. Please do not memorize or mug up the graphs of secant, cosecant, and cot, not needed. That's why I'm trying to explain a simple way to understand it better. Cos of half x. You know that the cos x pattern is always, you have to have a gentle pattern here. This is how the cosec graphs look like between, for this is the one cycle of the cos graph. You know the period is 2 pi and the amplitude is positive, I mean amplitude is 1. So the maximum is +1 and the minimum is -1. Now when you say half x, so this is a transformation that you studied in your AS level. So that this is a horizontal transformation with a stretch factor 2 parallel to the x-axis. You can either call horizontal transformation, or you can use the transformation with a stretch factor 2 parallel to the x-axis. It means that every x coordinate will be doubled. So here the period from 0 to 2 pi will be doubled for cos of half x. So the new period will be 4 pi. So I like to show you how this looks. This is only a sketch. So, but still I would like to, I'm going in detail. Sometimes here it is only 2 marks, but there's no need to skip this question and leave the 2 marks. It's very important. You need to just like show the sketch of it, but I'm going in detail a little bit. Please do not mind. So what you can do is, so 1, 2, 3, 4. This is 1 and this is -1. Now this is pi, 2 pi, 3 pi, 4 pi. This is pi, 2 pi, 3 pi, 4 pi. And this also minus pi, and this is -2 pi. If you're able to draw the sketch of the cos in a very simple and smooth way, in a fast way, it'll be very easy for you to draw the sketch of the secant graph. Drawing 4 minus x square is not a hard job. It's easy only, as you all know that. It's a parabola, opened on parabola, shifted 4 units up. Yes, so coming back to the sketch of the cos here, the cos is simply, you know, it takes the maximum here at 0 and 4 pi, and 0 at the pi and 3 pi. You know, actually the cos is 0 at odd multiples of pi by 2. Cos is 0 at pi by 2, 3 pi by 2, minus pi by 2, minus 3 pi by 2. So here, since it's been stretched with a scale factor 2. So minus pi by 2 times 2 will be minus pi. Pi by 2 times 2 will be pi. So you find, so cos will be 0 at pi's odd multiples of pi's here. Now, so this is how actually I'm drawing the cos, a simple cos graph. You can draw this with a pencil when you're working on the boards. Now, wherever you might be wondering why I'm drawing this cos curve. So since I know where my cos is 0, right? So the cos is 0 at pi and minus pi. So the secant will be undefined or infinite, because you know the reciprocal of cos is secant, and cos pi by 2 is 0. So secant pi by 2 will be 1 by 0. So we'll have a vertical asymptote there. Sorry if I'm going in detail, but to make you understand that secant half x graph is not that hard. Now, wherever you find the peaks of the cos graph, the secant just takes a turn over there. So, for example, I can draw a simple secant graph here like that. That's it. You're done. Yeah. So this is your secant half x, and this is your cos of half x. I mean, it shouldn't take much time. Now, so this is the professional way of sketching the curves. Please do not choose some x values like 0, pi by 2, pi within the interval, then find the y values and then plot them. And then that might look simple, but that's not, I feel like it's not professional. It's up to you. So yes, now coming to the 4 minus x squared curve. You know that 4 minus x squared curve is nothing but when you equate this to 0, you get the two x-intercepts, which is plus and minus 2. And of course, most of you know that pi value is 3.1 for something. So the 2 is, it's over here, and the negative 2 is over here. So your parabola will be, it's open down parabola. So that's how you sketch the parabola. Now all that it's required is you need to show that there is an intersection or a root happening for 4 minus x squared and the secant half x. So all this graphs and sketches is about just to show that yes, there is a root between 0 to pi. Yes, there is a root. That's what you need to indicate. Hope this is clear in detail. Okay. Now verify by calculation that this root lies between 1 and 2. Now what you can do is, what you're given is 4 minus x squared equal to, so secant of half x. Now you can consider that you can get the secant x half x to the other side. So consider f of x is 4 minus x squared minus secant of half x. Remember, when there is a root in between two x values, it means that there the sign change should happen. The function should either change its sign from positive to negative or negative to positive. So let's quickly plug in the x value 1 and 2 in the function. Now here it's very important that you have to put your calculator in the, not in degree mode, it's in the radian mode. Most of the people, they might be in a hurry, they use a degree mode here calculator, then you might get different values, or sometimes mistakes definitely will happen. So please please be cautious that you change your calculator to radian mode. Now when I plug in x equal to 1, I would get, so you don't have the option of secant in the calculator, so I can use a fraction symbol and use the reciprocal, like for example, you can use a fraction key in the calculator. So type 1 in the numerator and the denominator, put cos of 0.5 times x. So here in this case, x is 1. So it will be 0.5 times 1 is 0.5. So I'm getting 1.86, which is positive. Now let's check for 2. So 4 minus 4, 2 square is 4, minus 1 by cos of 0.5 into 2 will give you 1. That will give you minus 1.85. And this is negative. So there is a sign change happening at 1 and 2. Since there is a sign change happening at 1 and 2, therefore there is a root. Since f of x changes its sign, therefore there is a root. There is a okay. Now use the iterative formula xn plus 1. Now again, here the formula is given to you, so no need to derive the formula. So what you can do is, this is given as root of 4 minus secant of half xn. So the calculator is going to do the job for us. You can consider the initial x value as either 1 or 2. It will work. So when you put n as 1 here, you get x2 equal to. So I'll tell you a very simple way how to put this in the calculator. So the initial value is 1. So type 1 in a calculator and store your answer as 1. After that, you can check your answer is 1 now. So input root of 4 minus, so secant, so 1 by cos half 0.5 times, instead of xn, you'll type your answer, close a bracket, and press equal to, the first value you will get is 1.6913. So here it said 4 decimal places, the final answer to 2 decimal places. So you have to follow that. And now keep pressing equal to. Now I get it 1.5786. Now one more time you press the equal to, 1.6062, and x5 is 1.6000. x6 will be 1.6014, and x7 is 1.6011. You might be wondering why I'm taking too long. You have to stop until the final value match, the last two values match. So 1.6012, 1.6011, and finally it stops here because 1.6011, here the two values match, therefore you can stop. You can say the final value for the two decimal places, correct to two decimal places, it is 1.6011, rounded to two decimal places will be 1.60 is the final answer. Hope this is clear. Yes. So let's move on to the next question. Question number 8. Find the quotient and remainder when the polynomial is divided by. So you can use the long division method. So 8x cube plus 4x square plus 2x plus 7 divided by 4x square plus 1. So here the leading term is 4x square, here the leading term is 8x cube. So first check 8x cube by 4x square will give you 2x. So multiply with 2x completely. 2x into 4x square is 8x cube, and 2x into 1 is 2x. Subtract, change of signs, cancel. This becomes minus 2x. This, see the corresponding terms, 2x and minus 2x cancels off. We have 4x square plus 7. Now again the leading term here is 4x square and this is 4x square. So possibly it should divide only by one time. So multiply 1. 1 with 4x square is 4x square. 1 with 1 is 1. Again subtract, change of signs. 7 minus 1 is 6. Therefore the quotient is 2x plus 1. The remainder is 6. So that's the question. Now here is asking, hence find the exact value of this. So this is nothing but, we already got the quotient and the remainder. So integral of 8x cubed plus 4x square plus 2x plus 7 divided by 4x square plus 1 can be written as, we got the quotient. So we're going to use the first part, part A, in the part B. We already got the quotient 2x plus 1. The remainder is 6 divided by 4x square plus 1. So we have to integrate the whole thing between 0 to half. So let us split this individually. So integral of 2x plus 1 plus 6 integral of 1 by 4x square plus 1. Now integral of 2x plus 1 is normal integration. 2 times x integral is x squared by 2 and 1 integral is x. Between the limit 0 to half. Coming to this part, you can take out the 4 common out. So this will be x square plus 1 by 4 and that is 1 by 2 whole square. You might be wondering why I'm doing this. So as part of the 2020 syllabus update, we got a new formula, that is integral of 1 by x square plus a square is 1 by a tan inverse of x by a, and this is there in your formula booklet, nothing to worry. All that you have to understand what your a is. So a is half here. So this will give you 2 to cancel, you get x square plus x. Between the limits of 0 to half, 6 by 4 is 3 by 2. So 1 by a, so 1 by half tan inverse of x by half. So that will give you, so this 2 and 2 cancels off. Now I can, this will be x squared plus x, the limit 0 to half. This is 3 tan inverse of 2x, the limits 0 to half. Now plug in the limits now. So half square is 1 by 4 plus 1 by 2. When you plug in 0, it is 0. And this is 3 tan inverse of half. So 2 into 1 by 2 minus 0, it's 0. So 1 by 2 plus 1 by 4 plus half is 3 by 4 plus 3, 2 to cancel here. So tan inverse of 1. So tan inverse of 1 will be equal to 5 by 4. So 3 pi by 4. So you already have 3 by 4 common. 3 by 4 into 1 plus pi. This is your final answer. And please remember, never put your answer in the decimal values because it mentioned the exact value. Find the exact value. So this is the exact value. So hope it's clear. Now let's move on to the question number 9. So this is differential equations, and you see here this straight away it will strike us saying that apply the variable separable method over here. And of course that's the only method you have in the syllabus. So when you separate the variables, you get getting the y to the other side, dy by y equal to dx by x plus 1 times of 3x plus 1. Integrating on both sides. So, but before we start integrating this, we have to split that as the partial fraction. Very important. So this is the partial fraction. Generally, they always give like a separate part A and part B, but it's been clubbed as one equation here. So let's split this into partial fraction. This is a simple factorization type. So I can use a by x plus 1 plus b by 3x plus 1. Therefore, you get 1 equal to a times of 3x plus 1. Multiply this and multiply this. You get x plus 1 times of b. You can go for a simple substitution of proper x values. When you substitute x equal to -1, get 1 equal to minus 3 plus 1 will give you minus 2. But this becomes, when you put x equal to -1, this becomes 0. So whereby your a is -1 by 2. Similarly, when you plug in x equal to -1 by 3, get 1 equal to, now this time this becomes 0. -1 by 3 plus 1 will give you 2/3 of b. So b will be equal to 3 by 2. That's it. So here, so integral of dy by y equal to integral of a is minus half by x plus 1 plus b is 3 by 2 by 3x plus 1. So integrating on both sides, you have log y minus half. Integral of 1 by x plus 1 is log of x plus 1. And here it is 3 by 2. Integral of 1 by 3x plus 1 will be log of 3x plus 1 by 3 plus c. So 3 cancel. So we can combine this log of, this is nothing but log a minus log b, half common. So you get log of 3x plus 1 divided by x plus 1, and this is half times plus c, and that's equal to log y. It's only given y as 1, the initial condition, y as 1 and x is 1. So y1, x is 1, log 1 is log 1 equal to 1 by 2 log, plug in 1 here. So 3 into 1 is 3 plus 1, 4, 4 by 2, so you get 2 plus c, and log 1 is 0. 0 is half log 2 plus c, therefore your c is minus half log 2. Therefore, your final equation is log y equal to half log 3x plus 1 by x plus 1. C is minus half log 2. Now you can even combine this. You can take out this half common here, and this is log a minus log b. So finally you get half log 3x plus 1 divided by 2 times of x plus 1. And this is log y. So this, from multiply the 2y there, so that becomes 2 log y is nothing but log of y square equal to log of 3x plus 1 by 2x plus 2. You can get rid of this logarithm. The final expression is y square equal to 3x plus 1 by 2x plus 2. The problem is not yet over. It's asking find the value of y when x is 3. So substitute the y value, x value 3 here. So 3 into 3 is 9. 9 plus 1, 10. 2 into 3 is 6. 6 plus 2 is 8. So that is 5 by 4. Therefore, the y value is root of 5 by 4, or simply root 5 by. Hope this is clear. I know it's a little longer. So 9 marks, so 9 minutes. That's how the questions work. Yes. So coming to the vector question. So the point A is given as 2, 1, 1. The point B is given as 1 minus 2, 2. The first question is that find the vector equals of line AB passing through the A and B. You know R bar is nothing but OA bar plus lambda AB bar. So OA is 2, 1, 1 plus lambda. So AB is nothing but OB minus OA. So subtract the position vector of point A from position vector of the point B. So you get 1 minus 2 is minus 1, minus 2 is minus 1 is minus 3, then 2 minus 1 is 1. And that is your equation of the line passing through A and B. So can make this as one equation, 2 minus lambda, 1 minus 3 lambda, then 1 plus lambda. Find the acute angle between the directions of the lines A, B and L. So I have one line and you have an other line. Now let's say this is the line AB, not to scale, and this is the line L. So that's the acute angle we need, theta. Here we have R bar. This is for AB. What we have is 211 plus lambda minus 1 minus 3 minus 1 minus 3 and 1. And for the line, R bar is already given. That is 1 2 minus 3, 1 2 minus 3 plus mu. The direction of the line L, 1 minus 3 minus 2, 1 minus 3 minus 2. So if we want to find the angle between the two lines, always use the directions, consider the directions. So cos theta is the dot product between the two directions. So minus 1 minus 3 1 dot 1 minus 3 minus 2 by the magnitude of that. This will be root of 1 square plus 3 square plus 1, which is 11. And here it is root of 1 square plus 3 square, 9 plus 1, 10, 10 plus 4, 14. The dot product, you know how to do it. You multiply the x and x, you get, so minus 1 plus 9 minus 2 by root 14, 140, 154. So that will give you 9 minus 3 is 6, 6 by root of 154. Therefore, the angle theta is cos inverse of 6 by root of 154. Now again here it's saying in degrees. So please again recheck your calculator. Don't be in a hurry. See if it's maybe earlier we had already put it in radian mode for the iteration question. So change this again to the degrees. So cos inverse of 6 divided by root of 154 will give you 6 root of cos inverse of 6 by root of 154 is how much? 61 point. The calculator shows 0.86. So to the nearest 1 dp it is 61.1 degree. And show that the line through A and B doesn't intersect the line L. So for here this is the concept of the intersection of two lines. So let's write the two lines R bar for AB. So we got for AB we got 2 minus lambda, I'm sorry, yeah, 2 minus lambda, 2 minus lambda, 1 minus 3 lambda, and 1 plus lambda. So please make sure that you will not make many mistake in the signs when making note of it. And the line L R bar is 1 plus mu, 1 plus mu. Then you have 2 minus 3 mu, 2 minus 3 mu, and minus 3 minus 2 mu, minus 3 minus 2 mu. So minus 3 minus 2 mu, minus 3 minus 2 mu. So let me check once again. 2 1 1. So 2 minus lambda, 1 minus 3 lambda, 1 plus lambda, and then you have 1 plus mu, 2 minus 3 mu, and then minus 3 minus 2 mu. So here what you do is equate the two lines. The concept is very simple here. So 2 minus lambda equal to 1 plus mu, then 1 minus 3 lambda equal to 2 minus 3 mu, 1 plus lambda equal to minus 3 minus 2 mu. So from here, get the lambda to the other side, you get lambda plus mu equal to 1. This is equation 1. And here from this, you get 3 lambda minus 3 mu is minus 1. And then you have lambda plus 2 mu equal to minus 4. This is equation 3. So consider so consider so consider the first two equations. Let's do the simultaneous solving. So lambda plus mu is 1, and then 3 lambda minus 3 mu is minus 1. So multiply the first equation with 3. So you get 3 lambda plus 3 mu is 3. Then here you have 3 lambda minus 3 mu is minus 1. Add the two equations. 6 lambda equal to 2. Lambda is 2 by 6, which is 1 by 3. Lambda is 1 by 3. We can use the first equation. Lambda plus mu is 1. So mu will be equal to 1 minus lambda. That is 1 minus 1/3, which is 2/3. Now, if the lines intersect, then the lambda and the mu value that we got has to satisfy the third equation. So the third equation, let's consider the third equation. So if the lambda and the mu value, if they don't satisfy the third equation, then the lines do not intersect. So lambda plus 2 mu, this is the third equation we have. So let's substitute the lambda and the mu in this. Lambda is 1/3. The mu is 2/3. So we have 1 plus 2, 2 times 2 is 4. So we get 5 by 3 equal to minus 4. And this is absolutely not right. So this is incorrect, which means the lambda and the mu value that we got didn't satisfy the third equation. Therefore, can conclude that the lines do not intersect. The lines do not intersect. So this is how we prove that the lines do not intersect. So moving on to the last question we have. So there's a point M here, and it says prove that it's already the maximum point. We need to find the x coordinate, which is basically the differentiation concept. So y equal to sin x cos 2x So differentiating with respect to x, dy by dx equal to, we can use the product rule here. So sin x into cos differentiation is minus sine into 2 plus cos 2x times sine differentiation is cos. So this will give us minus 2 sin x sin 2x and cos x times cos 2x. So we have to find the x coordinate of M, and it's a maximum point. So the maximum point happens at the turning point or the stationary point. To find the stationary point, we equate the dy by dx to 0. Now minus 2 sin x sin 2x plus cos x cos 2x equal to 0. So sin 2x, use the double angle formula. 2 sin minus 2 sin x into 2 sin x cos x plus cos x. Wait for transforming the cos 2x. So here I see cos x common. So cos x into. So this will give you minus 4 sin square x plus sin square x plus cos 2x equal to 0. So cos x is 0, whereby you get x equal to pi by 2. But I don't think this makes sense because this interval, the x value pi by 2 somewhere. The M is between 0 and pi by 2. So here minus 4 sin square x. Now convert the cos 2x in the double angle of 2 in terms of sin square. So you have sin 2, cos 2x is 1 minus 2 sin square x equal to 0. You can also solve this problem in terms of cos also, and there's also a possibility that you can also do in terms of tan. That also can happen here. So this will give you 6 sin square x equal to 1. Therefore sin square x is 1 by 6, and therefore sin x is 1 by root 6 plus or minus. But since M is a positive, it's on the positive side of the x-axis, so we'll consider the positive value here. So x will be equal to sine inverse of 1 by root 6. Again, please change your calculator in the radian mode, not in the degrees, please. So sine inverse of 1 by root 6. That will give you 0.4205. Write the value first. 0.4205. Round it to 3 significant figures. 0.421. So this is the x coordinate of the point M. Next, so now we need to find the area. Find the area of the shaded region, and it's also said that you need to put the answer in the exact form, and there's something to do with the substitution. Go for u equal to cos x. Now here, if you look at the shaded region, one point, the left hand point of the limit is 0, and we have to find out what this x value is. The concept is, the function is sin x into cos 2x is 0. We know that sin is 0 at multiples of pi, 0, pi, 2 pi. So anyway, this is not going to help us, but cos 2x is going to be 0, and the possibilities of cos being 0 is odd multiples of pi by 2. So pi by 2, 3 pi by 2, x will be equal to pi by 4. So we're looking for the value less than pi by 2. So we'll consider pi by 4, because the other value will be more than pi by 3. Pi by 4 will be more than pi by 2, so ignore that. Therefore, you're going to integrate the area between 0 to pi by 4 sine x cos 2x dx. Now it said like use the substitution u equal to cos x. So now as I said, there are different versions or different formulas for cos 2x. So let me write once again. So this can be written as 2 cos square x minus 1, and also this is 1 minus 2 sine square x, and sometimes we also have this cos square x minus sine square x. Now since here it said u equal to cos x, that means you're going to replace the cos x with u. So you cannot transform the cos 2x in terms of 1 minus 2 sine square. Instead, we'll go for 2 cos square minus 1. So this will be integral of 0 to pi by 4 sine x. First write the step. So 2 cos square x minus 1 dx. Now go for the substitution. So cos x equal to u. So differentiating on both sides, you have minus sine x dx equal to du. Therefore, sine x dx will be negative du. Also make a change of the limits. So when x is 0, cos u is cos 0, and cos 0 is 1. And when x is pi by 4, you have u is cos of pi by 4, which is 1 by root. For this will be integral. When it's 0, it's 1. So 1 by root 2. So you have 2u square minus 1 times minus du. Now we have learned in the concept of the definite integrals that you can change the integration. If the integration has a negative sign, you can change the limits. And of course, you can see here, you have a higher value in the lower limit 1 and the lower value in the upper limit. So you can reverse the limits of integrations here, and you can compensate with that negative. So this becomes 1 by root 2, 2, 1, 2u squared minus 1 du. So this is a simple integration. So u square integral is u cube by 3 minus u between the limits 1 by root 2 and 1. So substitute 1 here, you get 2 by 3 minus 1 minus, now 2 by 3. So cube of 1 by root 2 will be 1 by 2 root 2. I'm not using the decimals here because it said the exact form. So minus 1 by root 2. So 2 to cancel. So 2/3 minus 1 is negative 1/3. So minus 1 by 3 minus. So here we have, this is 1 by 3 root 2. So 1 by 3 root 2, and you get a 3 minus 1. So you get minus 1 by 3 minus I'm sorry, no, 1 by 3 root 2. This is 1 minus 3, sorry, 1 minus 3, 1 minus 3. So that will give you minus 2 by 3 root 2, and that will give you, that is minus 1 by 3 plus 2 by 3 root 2. So this root 2 cancels, you get root 2 here. So and so minus 1 by 3 plus root 2 by 3. The final answer is, you have the same denominator. So it's root 2 minus 1, and that is the exact value. So hope you all understood the solutions for each and every question of the Feb March 2022 pure maths 3 to paper. So thank you for spending your time on listening to this.